What's up, everybody? Welcome to Geology. Let's take the last video one step further by not only considering the whole drainage basin, but now maybe in sections, which we kind of did, right? Up towards the source tends to be a little steeper, down towards the mouth tends to be a little bit flatter. But now let's add in what happens with flooding in those two areas, should you go and dump a bunch of water on top of it. I didn't do a new note sheet because it's pretty much based on exactly what this was in the last one. So go ahead and use that. Maybe if you want to add in, one idea we're going to consider is the relief ratio, which is kind of like, it's kind of like slope, really, only we're considering it with an area as well. So how much do you go up and downhill over like this area? Let's consider that black line as like a boundary. It's really just a cross section for this diagram, right? But what if we just considered this part of the basin up here? How much does it go up and downhill over how much and how much area would contribute water? Like, remember this whole definition of a watershed or drainage basin. It's the amount of land, the area of land that contributes to a stream system. So if I were to dump some amount of water on this, I've never really drawn with this program, but I bet you it works. If I were to dump some amount of water into that with a rainstorm, how hilly is it? That's really what relief is. It's hilliness, right? So if you're in a very flat area, like generally Oswego is, right, up near Lake Ontario, it's reasonably flat versus going down once you get like south of Syracuse or down to the Finger Lakes where you see it's reasonably hilly. And again, let's consider Chittenango Creek, which I'll pull up here in a minute. But since it's kind of hilly here, considering how much area it is, when water lands, what's it going to do? Versus take some similar area down here, like in a similar amount of real estate. If I were better at drawing, these two would be closer. But when water lands there, it's a lower relief ratio. It's less hilly per area, right? It's not going up and downhill as much. Now, I suppose one thought about that is going to be, what does the steepness do to how water flows? The steeper it is, the more water is going to want to run off on the surface versus the flatter it is, that allows water to have a little bit more time to infiltrate down into the soils. And there's other factors. There's like land use, there's the type of soils, there's underlying bedrock, plant growth. But if we just consider steepness, the steeper it is, the more water runs off, right? So if up here, the relief ratio we're talking about shows us that it's really steep, water is going to tend to run off more quickly into the stream systems. Whereas here, it'd be a little bit more slowly because it can have more time to infiltrate into the soils because it's flatter, right? So where are we going with all this? Let me get it together. So in your book, they're going to refer to these as upstream floods and downstream floods, or flash floods versus downstream floods. Check it out right there with zone 1, zone 2. And that's going to be the idea that's more flashy. It's a faster response where the relief is higher, where there's a higher relief ratio, because the water is going to fly into these stream valleys a lot quicker. So your lag time from rain event to flood stage is a lot less. They'll come in a lot quicker in the upper part of the basin, and then that lag time is a lot lower down here. So let's see if this actually is true. So what I did was I went to USGS monitors and found a couple of kind of actually cool maps here. So this is Chittenango Creek, the area that we've been discussing. I can pull it in on Google Earth here too from another monitor. All right, over here. So we looked at it in Google Earth the other day. Although I had the stream highlighted at my work computer. Steeper as you come up here, it's a little bit flat, right? But it's generally this like really steep gorge as you get down into this. And again, it's a pretty nice drive if you want to go take a day and check out Chittenango Creek, Chittenango Falls State Park. It's pretty steep as you work your way down this, whether Google Earth is reflecting that well or not. This map right here shades in gray the watershed, and then from the gauging station right here, the monitoring location that's where the stream comes from upstream of that, right? So what I'm saying, if I'm not lying, is that this upper part of the basin, where it's steeper, should have a more flashy response to rainstorms. So here we see it. Now there was it's currently the second. If you're watching this now, the 2nd of April, we had a pretty good storm come through yesterday. So if you see how steep this graph would be, the height in feet in the stream gauge, and this is just north of the town of Chittenango, so it's in that upper part of the basin, and you can see that like it just takes right off, right? That's a very steep line with it rising however much over the course of we could probably figure out the time here, but let's say not much, right? Oh, there's the times. A couple hours it goes up that fast in reaction to the stream, in reaction to the storm. I'm sorry, I should say. So now let's look lower in the basin. So what I did was, if we go back to Google Earth here, if we get down to where it's flatter, unfortunately there's no gauging stations down here, but if you go down all of these streams, we go into Oneida Lake, it's a lot flatter there, and there's just like a lag. It's a slower response. So if we go to that one, you can see that it still went up. I mean, it still rained, right? But what I'm trying to say is that that slope is way less steep. All right. Now, none of this led to flooding. The storm wasn't that bad. We'd have to, in our head, say, okay, in a flood scenario where the water, there was that much water coming in, how are these two curves different? This is a very flashy response, typical of an upstream flood, high in the basin, and this is a much slower response, typical of a downstream flood. So that in terms of like what the hazards are, these are the things that like boom come in and out, very, very dangerous and disastrous if you're right in that central location, right? But also tend to wrap up pretty quickly. The major floods that last like days to weeks, that's these. They might rise a lot more slowly, but they also linger for longer. Being downstream, there's more upstream of them to throw water down into the lower part of the basin. All right, so keeping those two differences straight in your head should get you through that part of the assessment. Hope that was clear. Let me know if not, and we'll catch up with you soon. Take care, everybody.